Right, in this video we're going to outline section 15.2 where we've made a transition to doing double integrals but over what the book calls a general region. Okay, and I just thought we would kind of look at the whole problem all in one screen just to kind of get a sense of what's going to happen in this section. Okay, so the first thing you're going to see here is that the goal is to try to set up a double integral of some function f over some sort of region. Okay, and it's the region that is shown here in the problem. Okay, so the region will be one aspect of the problem. That is the first thing to think about. Then there is a second part of the problem to figure out what sort of function that you are integrating. Okay, and we can see here from the eventual setup of this problem that we're integrating the function f of x, y is equal to x plus y. And that is what we are seeing right here. The part of the surface is the function x plus y, which is some sort of plane. Okay, so x plus y we know is a plane, but we're not finding a double integral over a whole rectangle. We are just finding the double integral over this region. So what we're seeing is that down here, if we could see through this surface, that there would be maybe I should draw this as a straight line, that we're seeing here this region in the xy plane, and the goal is to do a double integral which finds the volume below the surface but above the given region. And so what we're going to do with this double integral is to find the volume of this little orange section. Okay, so the next thing to notice is that once the region has been given to you, or you may even have to do quite a bit of work to find the region. So this region here may be given, or you may need to do like at least half of your work spent to find this region, right? You may have to read the problem and work pretty hard to get what this region looks like, okay? Now in section 15.2, we can see that there is something that we're going to have to be very concerned about and worry about, that dA. In the past, we've written just dy dx, or we know that you can write dx dy. And when we were integrating over a rectangle, it didn't really matter the order of integration. Okay, the order of integration didn't matter as much, dy dx or dx dy, because all you had to do was just reverse the numbers. But here we can see that depending on if you do dy dx, we may have the limits of integration. This is y going from x squared up to y going to 3x. And then the last integral, x could be going from 0 up to x is equal to 3. So here we're seeing a feature of a double integral that if the region is not a rectangle, you may actually have a functions for your limits of integration. Okay, and if you switch to a different order of integration, dx dy instead of dy dx, you may get different functions. Okay, in this case, this is x going from y over 3 up to x being the square root of y. And then on the outside, we see a common feature that y will go from a constant 0 up to y is equal to a constant 9. So in both cases, in both integrals, you have numbers on the outside integral, but you have functions on the first integral. Okay? Now that would be the setup phase of the problem. We know that doing any double integrals are going to require a setup. Okay, that setup would require that you look at the region and that you figure out what function it is that you're integrating. So that would be the setup. And then once you've got the setup, you can then move on to the evaluation phase of the integral. Okay, so this is just the general overview about what can happen with double integrals over general regions, that the order of integration matters, The order matters in the sense that you may have to change the limits of integration. The order will not matter in the sense that no matter which order you evaluate, you'll get the same number in the end. Okay? So your integrals may look very different from each other, but they should evaluate to the same number. Okay? The order matters when it comes to dy dx or dx dy in terms of the limits, but the number should be the same when you evaluate. So that's just a general overview of what we're going to see in section 15.2. In the rest of the video, we will make progress on doing some specifics.